What's going on, Alex Bros? I wanted to make this video for a couple of reasons. Number one, my online students currently are about to embark on a section involving logarithms and their graphs. And number two, I got a new headset, so I'm hoping the sound works out a lot better than my previous videos. Anyway, in this video, I'm going to give you a brief introduction into the graph of one type of logarithm, an example of it, and a little trick I've been thinking about that I currently developed today. So I'd like to premiere that and see what you guys think about it. So here we go. All right. So in this video, we're going to focus on sketching the graph of a log function. Here I have log base a of x as my original function. And keep in mind that if the base is greater than 1, the shape of the log graph will look like this. So that's when a is greater than 1. Whereas if a is less than 1, the shape of the log graph will look like that. Now this is prior to any transformations, okay, so I just want to shout that out in advance. Um, also, when sketching these things, I find it helpful to make a small table of values, and that's actually going to be pretty key to the trick that I'll be showing you guys in just a few minutes. So in general, the table that I like to use, I'll just make a quick f of x table, where I'll say x as my first column, log base a of x as my second column. So this is an xy table essentially. And there are going to be three x values that I include in this. The first x value is 0, then we have 1, and then we have a, which is the base. Now prior to any transformations, x equals 0 is actually not a valid input for the log function. Now keep in mind we can't have 0, nor can we have negative values inside of a log function. So for the y value for 0, I'm just going to call it VA for vertical asymptote. Now, if we were to plug 1 into log base a of x, we should know by properties of logarithms that the y value for that would be 0. And computing the log base a of the base itself, so when the argument matches the base, that simplifies to 1, again by virtue of properties of logarithms. So these are three key items that I'm going to transfer into the coordinate plane right now. So when we have x equals 0, there's a vertical asymptote. So that asymptote is going to go along the y-axis. X equals 0, which is a VA. And then we have the point 1, comma 0. So that's an x-intercept, which will go right here. Then we have the base, comma 1, which since I haven't chosen the specific base, I'm going to assume a base greater than 1. So I'll just put it randomly, let's say right here. I'll say that that's a, comma 1. So yeah, I forgot to mention that in this video, we're going to be focusing on the case where a is greater than 1 for my trick. All right, so I'm going to go ahead and connect these 2 points. So 1, comma 0, I'm going to connect that through a, comma 1. And I'm going to slightly curve it so that it slowly goes up to positive infinity. And to the left of 1, 0, I'm going to hook it down towards the vertical asymptote, heading down to negative infinity. But keep in mind that since this is a vertical asymptote, the graph is never going to cross or intersect. Okay, so this part right here, the left end, this tail of the graph, gets closer and closer to the y-axis without crossing or touching it, and it heads down to negative infinity. Whereas the right end heads up to positive infinity. Now, one phrase that I learned a long time ago, which really helped me out with logs, is that exponentials explode, whereas logs roll. So just imagine that, this is a graph that's just sort of rolling out to the right. Okay, so not sure if that helps, but if it does, feel free to steal it, just like I did. And we'll move on to the next part. All right, so an explicit example of this would be something like f of x equals log base 3 of x. Okay, let's first examine the base. The base is 3, which means that's a base greater than 1. So the shape of the graph prior to transformations will look like that. And I'm going to make a quick table of values for this. So we're going to have x, and then I'm going to write log base 3 of x. All right, and I'm going to focus on those three x values from my last graph. X equals 0, 1, and keep in mind the base is 3, so this next x value is going to match that. It's going to be 3. All right, there are no transformations here, so we can assume that when x is 0, we're going to land on a vertical asymptote. Okay, log base 3 of 1 is 0, and log base 3 of 3 is 1. Let's go ahead and transfer that into the coordinate plane. Okay, that asymptote is going to go along the y-axis. That's x equals 0. We'll have the x-intercept again of 1, 0. And now a specific point, 3, 1. All right, I'm going to go ahead and connect those much in the same way as the previous graph. Okay, again, the right end slowly rolls up to positive infinity. The left end rolls down to negative infinity without crossing or touching that vertical asymptote. Okay, so what happens when we have some transformations in the mix? So as you can see here, we have a modified version of log base 3 of x. We have a plus 4 inside the argument and a minus 5 behind the expression log base 3 of x plus 4, where I like to say that this is at the end of the function. All right, shout out to Lincoln Park, in the end. Okay, so if you're wondering what the trick is, well, I'd first like to give you sort of a generic form of this function right here. I'll say versus. Let me write log base a of x minus h plus k. So this is kind of a generic version of a log function when there's a horizontal and a vertical shift involved. So part of the trick is to write this function that we're provided in this format. So in other words, I want the inside of the argument to resemble subtraction, and I want the tail end of the function to represent addition. And there's a way to do that just by playing around with your signs. Okay, so I'm going to first rewrite this as log base 3, and I can write addition as a subtraction of a negative. So in other words, a double negative. That is, x plus 4 is the same as x minus negative 4. And in this situation, negative 4 would represent our value of h. As for the minus 5, I'm going to write that as plus negative 5. So negative 5 would be our value of k. All right, so we're getting to the good part. Okay, so I'm going to jot down that table from the most recent example, log base 3 of x. So we had x, then log base 3 of x. And remember the x values that I used were 0, 1, and 3. And the y values that we had, well, there was a vertical asymptote, there was 0, and then there was 1. Now I left a little bit of space behind the x values because this is where my trick comes into play. What I'm going to do is I'm going to take this value of h, which is negative 4, and I'm going to add it to all the x values. So I'll write that as x plus h. So that means to 0, I'm going to add negative 4. To 1, I'm going to add negative 4. And to 3, I'm going to add negative 4. At the same time, I'm going to take my k value, which is negative 5, and I'm going to add that to the y values. So I'll write that as plus k. So that would be the vertical asymptote plus negative 5, 0 plus negative 5, and 1 plus negative 5. And this gives me a brand new table of values, which will be the table of values for this function. And once we plot the points in asymptote, we will have incorporated both the horizontal and vertical shift, which tie into the values of h and k, -4 and -5. All right, so let's see what this table of values looks like. I'm going to write it as x and f of x. So this will be my official table of values. Okay, I know I'm kind of using x in two different ways, but I'm sure you can follow along with me on this. So if I do the calculations in this table to the left, I get a new x value of -4. I also get a new x value of -3 and a new x value of -1. As for the y values, okay, if I take a vertical asymptote and I add -5 to it, that's geometrically basically shifting up the vertical asymptote by -5 units. So in other words, we're moving a line down by -5 units, which actually gives us the same line. So I guess another trick to think about this is when you're adding or subtracting anything to a vertical asymptote, it just remains a vertical asymptote. Okay. As for the actual calculations, having the specific y values or real number values of 0 and 1, we can follow through with those calculations. So 0 plus -5 is -5. 1 plus -5 is -4. And this right here is going to be the table of values that represents, well, the table of values with points that would be on the graph of f of x. Okay, so at -4, there's a vertical asymptote. Then we have -3, -5. So let's plot that. Then we have -1, -4. Okay, and keep in mind our base is 3, which is greater than 1, so it should have this shape, which it will, since there are no negatives that would indicate any reflections. Okay, that could be for a different video. So in other words, I'm going to connect these 2 points going from -3, -5 through -1, -4 in the manner of rolling up slowly to positive infinity. And then to the left of -3, -5, we're going to go down to -infinity without crossing or touching the vertical asymptote. And that's the trick. Okay, so in summary, rewrite the function in this format. Log base a of x minus h plus k. That helps you identify your value of h as well as your value of k. And take your original x values from the basic form of the log function, add h to all of them. Okay, so you can think of, just using the values 0, 1 in the base, adding h to each one of those values. Okay, those will give you the location of the asymptote that help you identify the new location of 1, 0, as well as the new location of a, 1. And then add your k value to the original y values. And just keep in mind that your vertical asymptote plus any k value is just going to remain a vertical asymptote. Okay, so not to overladen you with some detail, but I do want to mention that -3, -5 is the new location of 1, 0. And then -1, -4 is the new location of 3, 1. All right, that's it, folks. If you stuck around this long in the video, thank you so much. If you found this helpful, feel free to smash that like button or leave a comment below. I hope to make some more of these to help make math a little bit easier for y'all. As being somebody that struggled with math myself and, just getting back up and continuing to take swings at it, I now understand it, and that leaves me the ultimate faith that you guys will understand it too. So hang in there, guys. Keep fighting, and one day, if you aren't already, you will be victorious over math. All right, guys. Thanks for watching. I'll see you in the next one.